This week I decided to do challenge problem 5.1. It says given n integers, prove that either one of them is a multiple of n or some of them add up to a multiple of n. And so I started off by trying to picture what this would look like. And so if n is 1, then we just have a set of 1, and technically all numbers are multiples of 1. So then I looked at n being 2. If n is 2, then at least one of our numbers is even, which satisfies that because that's a multiple of n. Or we have two odd numbers, and two odd numbers always add to make an even, making it a multiple of 2. So the first two cases were pretty simple. Then I was just being really literal. If n was 5, so then I just picked the first 5 integers. Obviously 5 is in there, and 5 is a multiple of 5. But you also have 2 plus 3. You have 2 plus 3 plus 5, which is 10. Lots of choices in here. Actually, if you added up all 4 of the first ones, if you added them all 5 together, that's a multiple of n. So it was really obvious that that was going to work. So then I just had Google generate 5 random numbers to make up a new set of for n be 5. One of them was 30, and then the other 4 are 98, 96, 24, and 44. Right here you can see 96 and 24 add up to make a multiple of 5. Obviously 96 and 44 would have been the same. I did one more just to really think about it, and so I did NB10. They gave me 30 again, which is a multiple of 10. 23 and 37 would be a multiple of 10, and then I had to add 4 numbers together, but still I could make a multiple of 10. And so I'm thinking through all this information, and I'm starting to come up with an idea for a proof. My thought would be it'd be a 2-part proof. The first part would be to remove all the multiples of n, as that is the quick solution, because that's half of it. The first half is, we could assume that if there is a multiple of n in there, then we're done. So then part 2 would be assume that a multiple of n is not one of the numbers. So then we're looking at the sum of some of our digits. So then I was thinking the pigeonhole principle for this. And so the pigeonhole principle, there'd be n plus 1 sums. You can add 2 of them together. You can add 3, 4, etc. So if we go back up and we look at 10, I could add 2, I could add 3, 4, 5, 6, 7, 8, 9, 10, or I could add all of, Anyway, so there's n plus 1 sums, but there's only n possible remainders when you're dividing by n, 0 through n minus 1, and so I thought that could be our pigeonhole principle. And that is about as far as I've made it. I haven't written up a formal proof or anything. I think there's going to end up being more to it than that. I paused for a second because this n plus 1, all of a sudden I'm not confident on that. And so I'm going to have to look more into that, and either I'm doing a quick misaddition as I'm speaking, or the n plus 1 is not correct, and I'm going to have to think that through again. So anyway, that's where I'm at with this. I would definitely love some feedback.